Welcome to EDU World Space.
In this problem, we will first use the concept of conservation of angular momentum, and we will take the angular momentum about point Q. So doing so, we get the following. Vector QA naught cross with M U naught plus Q B naught cross with 4 M V naught plus Q C naught cross with 4M V naught is equal to the angular momentum after, which is QA1 cross with MVA plus QB1 cross with 4M times the velocity VB plus QC1, vector QC1 cross with 4M times the velocity VC. And so this simplifies into QA naught cross with MU naught plus QB naught cross with 4M V naught plus 0 is equal to 0. First term on the right hand side is 0 plus QB1 cross with 4M VB plus 0. So we'll call this equation 1. But we need to find the individual terms in this equation. And we also have cross products. So once we find our vectors QA naught, QB naught, and QB1, we also need to use method of cofactors and find the cross product. So what we know is that vector QA naught is equal to the position vector of point A naught, RA naught minus RQ. So that's using vector mechanics or vector mathematics. And this is 300I plus 300K for vector RA naught minus vector R at point Q. The position of point Q is 240I plus 200J plus 100K. And hence we get QA naught to be 60 millimeters I minus 200 millimeters. Remember our positions here are measured in millimeters. Times J plus 200 millimeters K. So there's our vector QA naught. Similarly, QB naught is equal to delta x, the distance delta x, I plus delta y, j plus delta z multiplied by the basis vector k. And finally, QB1 is equal to the position vector at point B1 R B1 minus R at point Q. And if we do this subtraction, we get QB1 to be equal to minus 93 millimeters I, that's in the I direction, plus 20 millimeters in the J direction, plus 30 millimeters multiplied by basis vector K. So that is vector QB1. We also have the data that is given to us that U0 is equal to minus 600 meters per second I plus 750 meters per second J minus 800 meters per second K. And vector V0 is given as simply 600 meters per second times unit vector J. And finally, from the solution to problem 14.26, VB is equal to VB lambda B, where lambda B is the unit vector, and this is minus 303.21 meters per second I plus 643.18 meters per second J minus 91.88 meters per second K. So now we can calculate each term in equation 1, and we can divide by m. So the first term is Q A naught cross with vector U naught. And this is equal to, using the method of cofactors, I, J, K, Q A naught, 60 minus 200, 200, and U naught is minus 600, 750, and minus 800. And we get QA naught crossed with U naught to be 10,000 I minus 72,000 J minus 75,000 K. So that's our first term from equation 1. The next term from equation 1 is the vector QB naught crossed with 4 V naught. Remember, we divided both sides of that equation by m. And this is delta x in the I direction plus delta y in the j direction plus delta z times k cross with 4v naught, which is 2400 j. And forming this cross product, we get minus 2400 delta z in the I direction plus 2400 delta x in the k direction. And our final cross product is QB1 cross with 4VB. So again, if we use the method of cofactors, we get IJK for QB1 is minus 93, 20, and 30. And for 4VB, it's minus 1212.84. For J, it's 2572.72. And for K, it's minus 367.52. And so the cross product ends up being minus 84.532I minus 70.565J minus 215.006K. So essentially, we have all our terms in that vector equation. So if we collect our terms and resolve into components, we have the I component is 10,000 minus 2,400 delta Z is equal to minus 84.532. And hence we get delta Z to be 39.388 millimeters. Resolving the K components, we get minus 75,000 plus 2,400 times delta X is equal to minus 215,006. And from here, we find delta X to be minus 58.336 millimeters. So we can actually calculate our coordinates for x b naught and z b naught. Since y b naught is 0, our coordinate at point b naught, the x coordinate, is equal to the x coordinate at point q plus delta x. So this is 240 minus 58.336. And so the x coordinate point b naught is equal to 181.7 millimeters. The y coordinate at b naught is 0, and the z coordinate at b naught is equal to the z coordinate at q plus delta z. And this is 100 plus 39.388. Hence we get the z coordinate at b naught and the position of b naught to be its x, y, and z components, and its z component is 139.4 millimeters.